Hello everyone, welcome back. Today I'll be discussing the case control study design part 3, in which there'll be a practice problem. Then we're going to briefly review the different types of biases that occur in a case control study, then also review how we can do some important calculations in Microsoft Excel, and lastly discuss the importance of matching in case control studies. So first off, this is the practice problem. I will read it out loud. A case control study was conducted to assess for the association between hypertension and stroke. The sample size comprised of 170 patients. A contingency table was constructed based on the information that were extracted from the patient medical records. Now, these are three important questions that I would like for all of us to answer. The first one is create a 2 by 2 table in Microsoft Excel, calculate the odds ratio of developing stroke, and lastly, interpret the odds ratio.
So, as the problem stated, it states that we should create a 2 by 2 table in Microsoft Excel. So over here we have the PowerPoint, in which includes the information for the 2 by 2 table, and we're going to build it in Microsoft Excel. So what we're going to do is the following. So first off, we're going to highlight 3 rows and 4 columns down. And then we're going to click on borders and say all borders. Okay? Then what we're going to do is fill in the table. So the first part, of course, is the exposure status. So we have people who have hypertension, no hypertension. Also, you can see this as a risk factors for stroke, since we are still on the exposure status. And then also see, of course, individuals who are at risk of developing stroke. So of course, this will be cases, people who have developed stroke. And then here we have controls, individuals who do not develop stroke at all. And please do keep in mind that the 2 by 2 table can change. So like you can have controls here or cases here, but that all depends on the table. But I'm just teaching you the 2 by 2 table based on theoretically. So here, just put in the numbers here, 25, we have 30, we have 55, and we have 60, okay? Then of course, line these up. I really don't have a table at all in terms, sorry, not a table, a title. But if you were to put a title, you can just say a hypo, sorry, what would it be? This is a theoretical case control study. Okay, so in theory, we just let me do table one, theoretical case control study. That's good. Okay. Then of course they want us to calculate the odds ratio. So what we do is we have to take the odds of illness. Before we do that, let's just make things prettier in terms of, sorry, making things stand out, case and controls. So it's just easier for people to want to differentiate between the two. Then of course we could probably have the numbers pop out, the color red. It's just easier for people to view it. Okay, sorry about that. Just trying to zoom in for you all. All right, so let's do the calculations. So of course we have our columns and we have our rows. So we have C4, we have C5, so that's the odds of disease. That is the odds of disease. Or you can see it as what is the odds of someone, sorry, what is the odds of developing stroke, okay? Stroke among cases, that's a specific group. Okay, it's the same thing, okay? So what you do is C equals sign C4 divided by C5. That gives you 0.0833. Then of course here you have the controls, and the question will ask us what is the odds of being non-diseased, like this here. Let me type it up. And then of course we can do some other things. Um, what is the odds of um, how would I write this question? What is the odds of developing stroke among controls? Or yeah, odds of being non-diseased, not having disease, or what's odds of um, well, sorry, not developing stroke among controls. So of course you have your cells D4 and it's D5. So you have the equal sign D4 divided by D5. That gives you 0.916. Make sure that's clear. D4, D5 is fine. And then the question asks, what is the odds ratio? Sorry, it states calculate the odds ratio. So what you do here is you take a division. So this is located in C12 and this is located in D12. So you have equal sign C12 divided by D12. And that gives you their solution to calculate the odds ratio. There you go. Thank you all for listening. We're going to get right back into it.
In case control studies, we have something called matching. Matching involves selecting controls so that potential confounders like age, smoking status, socioeconomic status, you can even include educational level, are similarly distributed among the cases. So in matching, right, usually we have a 3-to-1 ratio in terms of you have three controls matched to one case. In the sense that, say you have the case, someone, they may have um, heart disease. So the controls, right, they cannot have heart disease, but they can have similar characteristics. In case control studies, we have different types of biases. These are the following: selection bias, information bias, confounding bias, recall bias, and misclassification bias. All these different types of biases will be discussed in future mini lectures. In case control studies, we have different types of advantages. So the first one is it's easier and it's faster to implement than a cohort study. A cohort study is another type of observational study in which we can calculate risk, and I'll discuss that in future mini lectures. Then second is we can study many risk factors. For example, for case control studies, we are selecting individuals based on disease status, and say the disease we're looking at is heart disease. So of course, there's many risk factors that come into play. So the first one is if someone has a high BMI. Another one is if someone has high LDL levels, or in this case, high cholesterol. So that's really good to look at. Then, of course, case control studies, they are suitable when studying rare diseases. And a rare disease, in this case, is a disease that has a prevalence less than 20%. Then, lastly, we have disadvantages of a case control study design. These are the following. So, first off, you can calculate only a relative measure of risk, which is an odds ratio. Then, recall bias is a major issue. Recall bias is basically stating that someone, they're not able to remember when they were exposed to a certain ailment, or when they knew they were had certain risk factors that made them susceptible to diseases. Um, Another one is difficult to select appropriate controls. So what we mean by that, in terms of, say we have a whole bunch of cases and we want to actually match them to controls. One, we have to make sure that the controls come from the same source population as the cases. And then two, we have to make sure that the controls, they do not have the disease of interest. Then the last one, second to last one, is difficulty in terms of establishing temporal relationships. This is a major issue because For case control studies, we are selecting individuals based on disease status. So we're not really trying to um, calculate the risk of someone developing a disease. That's why we can only calculate, in a sense, an odds ratio. And then lastly, we have can only study one disease outcome at a time, which is really crucial in a sense that, say, we want to select um, individuals based on, say, they develop prostate cancer, we can only look at prostate cancer and risk factors that are associated with that specific ailment. Thank you all for listening to this mini lecture. In future educational videos, I'll discuss another observational study design known as the cohort study. Stay tuned.